Good morning, guys. We are going to start with an electrical circuits lab. Okay, as we discussed in the previous lecture, this lab is not a separate course. It is a course with the necessary electrical circuits too. Okay, basically we are going to perform the electrical circuit lab in the two directions. One is software and another is hardware. Okay, so experiment one is basic measurement and basic law, that is Ohm's law, KVL, KCL and equivalent resistance. So in the experiment one we will verify all the laws what you have done in theoretically. Okay, and experiment two is the theorems of electrical circuits, superposition, Thevenin maximum power transform. You will perform one experiment in hardware, same experiment you will verify in the software, that is multi-sim. Okay, later on we will perform the theorems of electrical circuit analysis, superposition, Thevenin maximum power, experiment 3 measurement of AC parameters, experiment 4 is resonance in low pass filter, and third is fifth experiment, it is fifth experiment, this is experiment 5, this is three-phase circuit. Okay, so the week 1 you will perform basic laws in the hardware, and week 2 you will perform basic measurement in the software with use of multi-sim simulator. Okay, same way experiment 2 you will perform, third week you will perform here. Okay, next week you will perform in the software. So simultaneously you will do it like this. Okay, and you don't have any mid exam for this, and you will be having final exam for 15 marks and 10 marks for the day-to-day activity. Okay, so let us proceed with the experiment on what that is basic measurement and basic laws, that is Ohm's law, KVL, KCL. Okay, so as you know, what is Ohm's law? Ohm's law is nothing but V equals to IR. So experiment 1 is basic measurement and basic law, Ohm's law. It is V is proportional to I. So when V is proportional to I, that means when V is increasing, I is increasing proportionally. Okay, like this circuit, suppose it is V here I. Okay, that means when you increase the voltage, the current in the circuit will increase. Okay, so this is Ohm's law. So this is voltage current relationship. If you increase V, okay, the current will also increase. It is a linear type. Okay, here it is also increasing, but you can see depend upon the value of resistor. This is the value of resistor. The value of resistor is R here. So that means suppose R is 1 kilo. Okay, 1 kilo, if I am giving 1 milliampere current, 1 volt as a voltage, so you will get 1 milliampere as a current, because the resistor value is 1 kilo ohm. Here, wherein here the R, it is just decreasing, but it is the linear. Okay, when the current is decreasing, when voltage is increasing, current is also increasing, linear increase. Okay, so but here it is depending upon, here you can see the value of resistor R, and here the value of resistor is R1 and R2. Depends upon the value of resistor, the characteristic will change. Okay, so first experiment we will verify these three things. Okay, first V equals to IR, and this R based upon the when we keep 1 kilo ohm resistor, and how it is changing when you change the resistor value, how it is changing. Okay, so next part is Kirchhoff voltage law, KVL. You know, voltage in the whole circuit will be 0. That means here the voltage entering is V1 plus V2 and minus V3. If you take the closed loop, it is plus V1 plus V2 and minus V3 is equal to 0. So voltage in the whole circuit will be 0. And the Kirchhoff current law, current entering is equals to current leaving. Okay, just as to summarize you. Okay, current entering is current leaving. Sum of algebraic sum of the current is equal to algebraic sum of current leaving the node. Okay, voltage division V1 equals to, so when you have we want to find the V1, so, okay, what is the influence of Vs R1. Okay, this is the voltage across we have to find the voltage across R1, so it is R1 by total resistance. Okay, it is series, so R1 plus R2. V2. So voltage across R2 is Vs into Rs by R1 plus R2, voltage division. Current division same way, I1 is equals to I source by, if here it is R1 I1, okay, so I1 is R2 influence of the current I2, sorry, on R2 by R1 plus R2. Same way I2 is Is into R1 plus R2, okay, wherein here it is same resistance, here it is opposite resistance, okay. So series and parallel combination R equal is equal to, when it is R1 plus R2, when it is parallel, R1 by R equivalent is equal to R1 plus R2 by R1 plus R2, or 1 by R1 plus 1 by R2. This is R2, just make the correction, okay, this is R2. So whenever you start the experiment, it should have some objective. What is the objective? Training with the multimeter to measure parameters like voltage and current and resistance, whatever it is. The multimeter, okay, the word multimeter is new for you, I think. So multimeter means which can perform multitask, okay. So to measure voltage we need voltmeter, to measure current we need ammeter, okay, to measure resistance we need ohm meter. So when all these functionality are combined together, that is called as multimeter, okay. So you can evaluate, or you can calibrate voltage, resistance and current with the help of multimeter, okay. And this is the first objective, to get trained with the multimeter, okay, to investigate the relation between voltage, current and resistance in Ohm's law. So this is our second main objective. As I told you, we have to verify the Ohm's law. V equals to IR, voltage, current and resistance. Now to investigate the Kirchhoff voltage law and Kirchhoff current law. So this is also our objective. Kirchhoff voltage law means total voltage in the circuit is 0 and current entering is equals to current leaving, okay. This is voltage, Kirchhoff voltage law and Kirchhoff current law you have to verify. To apply the voltage and current division, just to apply the what you get the values here, you will apply the voltage law and current division law, okay. And finally we will find the equivalent resistance, okay. So for at the matter of the time, because of the reducing the course, we just will not perform this last part, okay. So apparatus means before you start the experiment you should have a clear idea, okay. So what are the components we are going to use? Here it is DC power supply. DC power supply, when we start the experiment I will show you what it is. DC power supply, 2 ammeter and group of resistance G1, G2, G3, G4. G1 is 1 kilo ohm, 2.2 kilo ohm, 4.7, 100, 220, 470. These are the group of resistance, okay. So before we start the experiment, let us have a clear idea of the circuit, okay. So circuit, when you hear the word circuit, it is a closed loop, okay, because this is from 0 to 12 volt, okay. The voltage we are applying is 12 volt, voltmeter, ammeter and the resistor, okay. So here group 1 resistance 1 kilo, 2.2 and 4.7, okay. Here connected circuit as shown in the figure are equal to 1 kilo ohm. So I will show you the circuit here, how we have connected, okay. This is the same circuit. Voltage, ammeter and the resistor. So here you can see this is the multimeter, okay. Here it is, so here it is V dash ohm, okay, voltage ohm. Here you can find milliampere, okay. This here you can find milliampere and 20 ampere, and this is the common. So this thing, this is the red, this is red, this is red, and this is the common black. So that means you will measure voltage at this point. You will use these two to measure the voltage, okay. You will use these two to measure the current. So what are these buttons? These buttons are like, if I want to measure the voltage, if I am using this two, I will click this button. So that means when I click this button, this is working as an voltmeter. Okay, this device is working as an voltmeter. Okay, if I remove this and if I click this button, so this is milliampere here. Okay, so if I use this two, it is working as an ammeter. Okay, same way if I click at kilo ohm, if I use this two, it is an again ohm meter, or to measure the resistance. Okay, so let us proceed with this. Okay, so here you can find, so this is yellow. Okay, this is the voltage ranges. So you can measure from 200 millivolt to 1000 volt. I can measure with this device. Okay, and for milliampere, for the current, I can measure from 200 microampere to 20 ampere. Here is the maximum range is 20 ampere. I can measure from 200 microampere to 20 amperes, and from the for the resistance from 200 ohm to 20 mega ohm, I can measure this. Okay, these are the ranges. Okay, these are the ranges where you can measure the voltage, current, and the resistance. Okay, this is for the resistance, this is for the current, and this is for the voltage. So these are the ranges from 220, 200, and 2000, and same way. Okay, this is our circuit. Okay, so what we are going to perform here, we are going to perform connect Ohm's law. Okay, so what is Ohm's law? First of all, Ohm's law is nothing but V equals to IR. We are using the resistor 1 kilo ohm here. So when you start the connection, so here we will start with the connection. Okay, so 0 to 12 volt supply. Here you can find 0. Okay, this is the common, and here 0 to 12 volt supply. Okay, this is the power supply, what just I told you, DC power supply. Here you can find DC power supply 12 volt. Here you have two ranges. Okay, 12 volt fixed and 0 to 12 volt DC. Okay, variable. 0 to 12 is variable. So here on the device you can find 15 volt, 12 volt. Here it is fixed. Okay, when you, this is the knob. Okay, just if you take up, it will be 15 volt. If you take down, if you just make it down, it is 12 volt. Okay, and this point is used for fixed voltage. Here 0 to 12 volt, it is a variable. Here this knob, if I just vary from 0 to 12, this is a variable voltage. Okay, if I use this point, this red point, it is a variable power supply, and this is the fixed power supply 12 volt. Okay, we have two things. This is the DC power supply. Okay, later on, just this part is for DC, and this part is for AC. In experiment 3 we will study about this. Okay, now meanwhile just we will study about this experiment and experiment 1 and 2. Okay, this is the common point, and this is the variable. See, we can change accordingly from 0 to 12 volt. I can change by using this variable knob. So let us start the connection from here. 0 to 12. 0 to 12 means 0 to 12 to the ammeter. 0 to 12 is here. So I'm using this as an ammeter now. I'm using this as an ammeter. Okay, when I click the button at milliampere, it is an ammeter. Okay, it is 0 to 12 volt. I'm using from here to the ammeter. Just here, just I told you, when I make connection on red as an ampere, this is working as an ammeter. Okay, and from 0 to ampere, from common we will connect to the 1 kilo ohm resistor, like this. Okay, from this point to this point, okay, to the ammeter. Later on we will connect the voltmeter. Okay, from this point to this point we are connected to the ammeter. Okay, from this point we are connected to the resistor. From common I am connecting to the resistor 1 kilo ohm. Okay, this is 1 kilo ohm. You can find the range here. Okay, and the other end of the resistor is connected to the zero. So as you can see here, other end of the resistor is connected to the zero. Now we will connect the voltmeter. Voltmeter is easy. In the voltage we measure across the resistor. Okay, so this is our closed circuit. Okay, we are going from here to the resistor, from this point to the resistor, and resistor to the ground. So now I will connect from here to the voltmeter. Okay, from this point to this point. This point to this point is nothing but resistor. One point is going to the voltmeter, another point is going to the voltmeter common. So common is one in. So just to make sure we are using black wire. Okay, no problem. You can use any type of wire. Okay. So from these 2 points I'm connecting to the resistor. Now power on. Just when you click the green button, it is power on. Okay. So now you can see here, this is the circuit. Okay, this is working as an ammeter and it is working as voltmeter. Now I will change the voltage from here, and you will so I will change the voltage. Okay, from 0 to 4, 6 to 10, and I will take the corresponding currents from the with the help of ammeter. Okay, later on I will draw the graph here. First I am using R equal to 1 kilo ohm, then I am using R equal to 2.2. First what we are going to use is 1 kilo ohm, and we will take the values. So let us see the values here. So R equal to 1 kilo ohm, power on. Okay, green light, power on. So now this is voltmeter. Okay, from voltmeter we will change the voltage accordingly. Okay, sorry, this is voltmeter. Okay, to see exactly, this is 1 kilo. Okay, 1 kilo means 1 into 10 power of 3. So here the voltage is 2.21 volt, not kilo or not milli, it is volt. And here you can find exactly 2.21. here it is 2.21, but it is in milliampere. So when you multiply V equals to IR, what is my V? 2.21. I is 2 into 10 power of minus 3. What is R? 2 into 1 into 10 power of plus 3. 10 power of minus 3 and plus 3 becomes 0. So V equals to IR is proved. That means 2.21 into 10 power of minus 3 by 10 power 10 power of minus 3 into 10 power of plus 3. Plus 3 minus 3 goes 2.21 equal to 2.21. That means V equal to IR is proof. Hence we prove Ohm's law, right? Okay. It is 2.21 and it is also 2.21 when the resistor value is 1 kilo ohm. Okay, just I make the tabular form. Okay, R equal to 1 kilo ohm. At 0 it is, that means when you do, there is no voltage, there is no current, 0. It is 0. Okay, let us make voltage exactly to 1.98. It is 1.98. That means for 2 it is 2, for 4 it is 4, for 6 it is 6. Okay, simultaneously you will do the all values. For 3 it is 3, for 4 it is 4, exactly same value, because we are using 1 kilo ohm resistor here. So same way we got for 0 till 10 to 10. Now we have changed the resistor from 1.1. You can see here it was 1. Okay, just I have removed from this point, I have connected at this point, just from here I have removed the connection from here and connected here. So it is 1 kilo ohm and it is 2.2 kilo ohm. So let us see at 2. So exactly we don't have 2 kilo ohm. Okay, so just I have used 2.2 around. So why it is coming in the reverse way? Now accordingly we have changed the resistor from 1 kilo to 2.2 kilo. Okay, so just remove from here and connect it here. From here just make it the connection like this. Okay, now approximately our resistor value is increased to 2.2. okay, approximately double, suppose. Okay, now if I give 2 volt as an input voltage, so the current will be approximately 1. Okay, half, because now we are increasing the voltage. Okay, and resistor value is also increased, then current will decrease accordingly. Okay, V is proportional to I. When we are increasing V, I is also increasing, but depends upon the value of resistor. If the resistor value is high, that means less current is passed through it. Okay, so previously resistor value was 1 kilo ohm, so output was same. What was the input, the output was the same. So now it will be, the current will be half that of the voltage, because we have increased the value of voltage here. So let us see. Now we increase it to, voltage is increased to 2. Okay, the current is 0.93. Just tablet this all values. 0.91. Just tablet is all values. For 0 it is 0.91. Brothers, just stop the video and write the values in the tabular form provided here. Okay, just write all the values. Okay, accordingly you can draw the graph. Okay, V versus I. This is V. To just write the scale. Okay, if you are using x-axis as 1 unit equals to 1 volt, just write it. Okay, so 1 2 3 4 5 boxes are 2 volt, 2 4 6 8 10. Accordingly, just so here you will get something like this linear. Okay, and for this, because same inputs, output is same, so linear straight line, and here you will get something like this. Okay, so here we conclude the first part, that is Ohm's law. Now we will come to the second part, that is, let us conclude the video. So just only we have changed the connection from here to here and here to here, that's it. Okay, so I have run for the whole values. Okay, as you can see accordingly. So here the 2.72 for 7 it is 3.45. So now we are going to perform Kirchhoff voltage law and voltage division. Kirchhoff voltage law and division. So this is a circuit diagram. Okay, this is a bit tricky. Okay, here again we are using voltmeter and the ammeter, but the resistance R1 is 100, R2 is 220, and R3 is 470. So all are connected in series. So you can see something difference here. The voltmeter, it is connected like this in the full circle. Okay, here it is dotted circle. Okay, so that means first I will connect this ammeter. Okay, this will be short. Okay, this will be like it is like this short. Okay, first I will connect this and I will short this too. Okay, from this. Okay, so first I will connect this, short this too. I will like this, I will short this too. Okay, second I will connect this ammeter and short this too, like this, and short this one and this one. Second time, and third time I will short this and this ammeter I will keep. Okay, so I will show you how to. Not going. I don't know why. No problem. So now again from 0 to 12 volt, from 0 to 12 volt, okay, from 0 to 12 volt, ammeter is connected to R1, R2 and R3, and voltmeter will connect here. So it is 100, 220 and 470, all are connected in series. Okay, all are connected in series. Now from 0 to 12 volt I will connect to the ammeter and voltmeter in the parallel. This is the tabular form. This is the tabular form, you can see here. This is the tabular form R1, R2 and R3. Here the R total is for 100, 220 and 470 will be around 100, 220 and 470 will be around how much? 690, right? 790. 790 is the total resistance. Okay, this is our total calculated. Now we will do the calculated version, and the from the ohm meter also we will measure the total resistance. So from here, from 12 volt variable I am connecting to the ammeter. Okay, from here I am connected to the ammeter. From ammeter I will connect to the resistance 100 ohm. Okay, from 100 ohm they are connected in the series like this. They are connected in the series. R1, there is no ammeter here. Okay, there is no ammeter here. So there is no ammeter here, it is short, and this is also short. So when this is short, that means R1 and R2 and R3 are connected in series. So same way R1, R2 and R3 we are connecting in series. Same here, as it is shown here, R1, R2 and R3 is connected in series. It is short. Okay, so R1 short, and from R3 I am connecting back to the, from R3 it is being connected back to the, from R3 it is being connected back to the 0. So this is your complete circuit. Now I will connect voltmeter across R1. Okay, let us see drop, is there any drop in the voltage. before it we have to set the voltage of the circuit to the 10 volt. Okay, I will set the voltage to the 10 volt. It is set, already set. Okay, no problem, already I set it to 10. Connecting to the voltmeter is connected across V1. Okay, so I will connect voltmeter across V1. So here it is, sorry, R1. We will measure the voltage here. Okay, so here I will connect the voltmeter and let us see the value 1. So it is reverse, just make it reverse, so you will get positive. So if you connect in the reverse way, you will get negative. Okay, no problem, it is the same thing. 1.26 is the voltage drop across R1. Okay, when you connect the all resistors in the series and you want to calculate the voltage, there is the voltage drop across each resistance. Okay, when current is same in the series and the voltage is different in the series, so write the current here. So current, it is, sorry, it is covered 12.59 and the voltage is how much? 1.26 or 25, it is 25. Okay, so 12.59 is the current. Okay, 12.59 is the current and 1.25 is the voltage across R1. So now what we are going to do is we will connect the second ammeter in between R1 and R2. We will just, I have to remove here these two. You can see I remove these two series connection and I put the ammeter in between, and I will just see what is the change in the current. Here it was how much? 12 point something. So is there any change when it is connected in the series? So let us verify with now I remove this ammeter. And from here it is connected to R1. Okay, from this point it is connected to ammeter. Okay, so here in this scenario you are using one ammeter at a time. Okay, first ammeter will calculate total current here. Now after R1 we will calculate the current, and this is short and this is short. Okay, there is no ammeter here. Third, we will short this two, and I will just put this ammeter and calculate the current. So our main aim is to calculate the current and voltage across after voltage across the resistor, and after each resistance is there any change in the voltage. We are going to say this. Okay, so from power supply to R1. Okay, power supply to R1, and from R1 to the ammeter. From R1 I am connecting to the ammeter, from R1 to the ammeter, okay, from ammeter to the R2, okay, and these two are connected in the series, and from here it is there. Okay, I will connect the voltmeter across R2 now. Now we have to calculate the voltage drop across R1. I have calculated. Voltage drop across R2 I will calculate now. Now you can see the current, it is same. In this scenario current is same, but the voltage it is changing. So now the change in the voltage is 12.59. It is same because series current will not change. So now voltage drop across each resistance is different. R1 is 1.59. It is 2 point something here. So now voltage drop across this, and now I will calculate voltage drop across R3 by removing the two ammeters and connecting this ammeter. Okay, so remove the series, then put the series over there, remove these two connections and put small wire in plus R2 to R3 and connect R1 to R2 in series. Okay, and from here we will connect to the ammeter, from R2 to ammeter, and from ammeter to the R3, and from here it will go to the ground. So now the current is 5.90, sorry, voltage is 5.90 and 12.5 is your current is same, so 5.90. just tabulate this value from this table in the table provided in the textbook. Just go to this table and write the values here. Okay, the current is same here, voltage is 1.59, 2 point something, 5 point, okay, and write the total voltage here. It will be around, so it should be around 10. Okay, so one point five six, 2.77 will be around, it will be around 10. Okay, you have to write this. It should be equivalent to 10 volt, because here we have given input voltage as 10. Before we start the experiment we have given the input voltage as 10, so the volt just the what is KVL, total voltage in the circuit is 0, so that means 10 volt. You have provided 10 volt there, total voltage will be around 0. Okay, now simple, just calculate R2 by R1. What is R2 by R1 here? Let us see. R2 by R1 is, what is R2? 100 is R1, 220 is R2, and 470 is R3. So just write R2 by R1, R3 by R1. Just take the values from here and do the calculation. It is simple calculation. Okay, so now here we will calculate with the total R total, measure using Ohm's law. So what is Ohm's law? V equals to IR. So what is R? R equals to V by I. So V is 10, and just put the values and you will get the total resistance, total resistance. Okay, so this is the theoretical. Okay, if you perform R1 plus R2 plus R3, you will get R total as in the figure. Okay, so what is R calculated? R calculated means we will connect the ohm meter across, so it is again 100 plus 220 plus 470, it is series, so just it will be 790. So here R calculated is for 790. Just write R23 is equals to R23 will be how much? 220 plus 470. Just do this and apply the voltage divider. Just we have seen the formula here. What is voltage divider? V1 equals to Vs into R1 by R1 plus R2. Perform, you can, from this formula you can find V1. Okay, so now calculate this R2 R3 V1 using the voltage divider. Next, KVL, Kirchhoff current law. When you go to the Kirchhoff current law, here also you have, sorry, this is Kirchhoff current law. Okay, so here also you have dash lines for the ammeter. Okay, first you will connect this ammeter, short these two. We don't need these two at a time. Okay, then we will same way connect this ammeter. Okay, connect this ammeter, short these two, then remove this ammeter, connect this ammeter and take the current I1, then take current I2, third step. Okay, so R1 R2 is 100 and 470. Calculate the voltage I1 I2, then total current. Okay, here it is total current. Okay, so let us start the experiment here. So to same way we will connect the ammeter, first this ammeter, and then this, from this ammeter will take the total current. Okay, here it will supply to R1 and R2, then from the current flowing it is I1 here. I will measure it with this ammeter. Okay, and I2 I will measure with this ammeter. So it is I total, then short it. Okay, calculate I1, then short this. Okay, then short these two and take I2 here. Okay, let us make the connection 100 and 470. Short. Okay, ammeter from 0 to 12 volt is connected to the ammeter. 0 to 12 volt it is connected to the ammeter. Okay, here we are connecting to the ammeter from this point to the ammeter, this point to the ammeter here. Okay, from ammeter to the 100 ohm, this way, from ammeter to the 100 and to R2. So R1 and R2 you can connect this. Okay, R2 R1 I have connected, and anywhere you can connect this, either here or here. Okay. Either here, this black one you can connect here or here, because these two are in parallel. Okay, here also it is parallel. Short it, and from here this point you will connect to the anywhere. Connect here or here, anywhere. Okay, so now our circuit is completed. Now we will connect the voltmeter across these 2 points. Anywhere if you from here to here, if you connect the voltmeter, you can see voltage will be same here and current is dividing. Okay, here the current is dividing. Previously we find the voltage in the Kirchhoff voltage law, voltage was dividing. That means voltage was dropping across each. Now in the current Kirchhoff current law, we will see the current division. Okay, so we will apply the current division here. Connected to this point. Okay, from here to anywhere you can connect either here or here. From these 2 points you have connected here. Okay, let us take the voltmeter and connect to the anywhere. Okay, either here or these 2 points you can connect. Okay, either this 2 point or this point. Because already we have set the value to the 10 volt. Okay, Now just I will show you. We till now I told you these are the ranges. Okay, when it was at 20, because the current, when we are measuring the current, it is showing 1 distance. It is not because it is not any value. So why it is not showing you the value? Because here the range is 20. When I click the button at 20, the maximum range is 20 here. Okay, so your ammeter cannot read more than 20 here. So now I will increase the range to 200. Okay, when I increase the range to 200, you can see when I increase the range to 200, let us click at 200. Okay, now you can see the reading. Okay, because 120 is more than 20, this 20. Okay, this 20 is a limit. Okay, after 20 you cannot see the value. So to increase the limit, you are having press the button of 200 range. Okay, so it is 120.4 is my total current. I total is 120.4. that means here you can see at this point it is total current entering here. When it comes to this point till here, it is 120 I total. Okay, here it will be I1 and here it is I2. Okay, so second part we will find I1 and I2. Let us just make sure the connection again. Okay, these two are short parallel connection. Okay, from this point to this point. So this total voltage is 9.89 around 10. Okay, so we are measuring the total voltage here. So the next part is I will remove this ammeter and I will keep ammeter here. So that means I will short this two and can take the reading of I1. Let us see this. So now R1, R2, here it is R1 and R2 and I total I1 and I2. Okay, so here we are calculating I1 and I total. Okay, we got I total as 120 and V as 9.9. Okay, so let us tabulate these values over in the tabular form and just make sure we connect to the second ammeter. Sorry, it is not 120 here. So I will make the correction. Okay, I will connect to the ammeter. From here we will connect directly to the C. So from here we will connect to the R1 and R2 supply. I will connect because now this is short. Now these two are short. Now I will connect this ammeter. Okay, so let us connect this ammeter here from this 2 point. Okay, these two are short. Okay, from this point I will connect to the ammeter. Okay, supply is connected at this 2 point. Okay, ammeter, let us take the wire, connect to the red point from here to the ammeter. Okay, from ammeter to the 0, common of the supply. Okay, and from here, from this point to the again common, from this point to the 0. Okay, just make the extension and make it to 0. So it is how much? Now the current I1 is 99.5. So I total was how much? It was 120 around, and I1 is 99.5 because the resistance value here is 100. Okay, so let us see the voltage again. To verify voltage is same. Okay, voltage is same because voltage will not change in the when it is connected in the parallel. Okay, just make sure the connections. Okay, the connections are perfectly fine. Just tabulate the values in the tabular form. connected meanwhile. Now I will short I total. This is I1. Okay, now I will take the value of I2. This should be equal to this one. Okay, so let us write, just reconnect the circuit, just remove and just swipe it. Okay, anywhere you can connect it. Okay, just down, just remove the ammeter and connect to the R2. So now you can find the current as 21.4, and again the voltage is same. So there is no change in the voltage. That means it is in parallel. So parallel, there is a voltage change. There is no changes in the voltage, and the current it is 21.4. So when you make the sum, it will be around 120.4. So hence our aim was to prove the Kirchhoff current law. So Kirchhoff current law is proved. I1 plus I2 is equals to I total. Again same calculation, R1 R2 by R1 is R2 is 470 by 100 is 4.7. I2 by I1 is I2 is around 21.4 and I2 is 90 point something. Okay, just take the value from the tabular form and do the calculations. So hence we conclude our experiment. Okay, so 4.4 equivalent resistance, just we equals to I. Just take the formula of Ohm's law and just do the calculation, and I have totally calculated. Okay, so just write V equals to IR. Okay, so the total resistance R1 and R2 is 570. Is it? No, not 570. It's not in the phase. It is in the parallel. R1 1 plus R2 by R1 plus R2. Okay. Make sure that I get the connection. This way we conclude our experiment. Okay, so just complete the report and submit it to me, okay, before the deadline. Thanks for watching the video, and if any doubt you can contact me or you can comment in the comment section. Do like, share or subscribe.